Brett, welcome to Talk Python Me.
Thanks for having me.
Yes, it's really good to have you here on the show. I just cut out on the video, but I think I will be back. Oh my gosh, give me a second here. What is happening to me? Hold on, Brett.
That's okay.
I think I need to switch my video. Let's see if that works. There we go. I'm back. How about we start over with that? Welcome.
Yeah, well, StreamYard keeps blinking me out for myself too, so I wonder if it's StreamYard.
Yeah, okay. Yeah, I'm going to blame StreamYard. Give me 1 second. Everyone, sorry for the false start.
Yeah, sure.
Let me just make a quick little adjustment to get my shoulders back. There we go. Okay. Now I have a green tint around me, but it's okay. Brett, welcome to Talk Python to Me.
Thanks for having me, Michael.
Yeah, it's great to have you here. It was good to see you at PyCon. It was a lot of fun there. I think, that was my first conference back since the before times. So it was really good to see a lot of people, even though, it's still, I think, finding its feet after.
Yeah, I mean, it was my deck just because I had Packages like 2 months prior, obviously at a much smaller scale. But yeah, it took a bit of adjusting after getting to the conference to get my.
It did, although
all of those people, so it was a weird feeling.
Yeah, it was definitely a weird feeling, but it was great to be back with people. I think we might still be having technical difficulties. Just let me know how it comes through on your side, and we'll see if we got to juggle things a bit. But yeah, it was really great to see you at PyCon. It was great to see everyone there. I'm looking forward to next year already. I'm hoping that it picks up some speed. I know a lot of people were a little bit nervous. I think not all the people who I expected to see there necessarily came back yet. So hopefully catching up with even more friends next time. But the parties were great. Seeing people that I only get to see, like normally we get to talk like this, but we got to talk in person there. And it's really nice. And for those of you who haven't gone or haven't gone for a while, Pittsburgh coming up.
Yeah, I'm looking forward to it. It should be a lot of fun.
Yeah, absolutely. So it's been a little while since you've been on the show. Not too long. It was last time you were on, we were talking about PyScript, MicroPython, I believe. Had you on for that along with some other folks. And yeah, so you're one of the top guests of the show. As you can see, people visit the guest page. There's a lot of stuff that you've talked about. And this time we're here to talk Language Summit. Before we get into that, though, let's just get a quick catch up. What have you done? What have you been up to since the last time you were on the show? What is that? Not quite a year ago.
Oh, boy. Yeah, I guess this would have been. So let's see here. Continuing on with the WebAssembly stuff. Had the first WebAssembly
carrying that torch. I know you're a big supporter. Yeah.
Yeah, trying to keep that in WASI specifically going for Python and hoping to get that to a tier 2 language, which we'll probably touch on for one of the topics in terms of what the tiers mean by the end of the year if I'm lucky. Otherwise, I'm still plugging away at trying to get us lock files in the Python community in some official standard way. It's going slower than I was hoping, but I'm still trudging along. And then otherwise, got some ideas around the Python launcher for Unix that I'm not quite ready to share yet, but we'll hopefully make it to Python Bytes when it does.
Yeah, just let us know, and it sure will. That's a great project. Lock files. We're talking like requirements.txt and then maybe pyproject.tom or pip what are we talking lock files here? Where are you focused on? What are you aiming for?
Yeah, something that kind of takes care of, that provides a standard around a file format that some tools like pip tools historically have used requirements.txt files for. Poetry uses poetry.lock, or I believe it's pipfile.lock for pipenv. Basically,
Yep.
the fact that we just don't have a standard around this, and every single tool comes up with their own solution, and just thinking through what would a standardized file format look like. I did try to make this happen 2 years ago. I spent 10 months on a PEP that ultimately got rejected in February of 2022. So I'm now taking the tact of, I'm going to just make it work for my project and show the viability of it. And then hopefully that'll be enough to get the community kind of going like, yeah, this is a good idea, and have the buy-in that I need in order to get a PEP accepted. Because the last time it didn't work out because I didn't want to support source distributions, because that's kind of a tricky scenario in terms of trying to get reproducible Python environments. And so
sure, and we're kind of moving away from that, right? With
people
wheels, and
didn't like that idea.
yeah, we're kind of moving away from that by focusing on
Yeah, I
wheels
think so.
and that kind of thing, right?
Yeah, I would say I think a lot of people are kind of starting to view source distributions as the source of truth in terms of building things from scratch, right? Whether it's large corporations that build things from scratch, or Anaconda even, or all these other platforms that do that. But ultimately, wheels are what you're consuming and installing. Like even today, if you were to download and install something using pip, if you don't have a wheel, pip actually builds you a wheel behind the scenes and then installs that wheel. So it's still ultimately what you're typically installing. And so I want to kind of get us lock files that are focused explicitly on wheels, just because that's typically what you're working with anyway. And just honestly,
sure. And the edge case scenarios, the edge case scenario can just deal with whatever they need to do, right? They don't necessarily have to fit into this packaging story, but if you're going to target the main use case, that makes a lot of sense. I think there's we're kind of in that 1,000 flowers blooming time of packaging, right? And it hasn't quite settled out what the community's decided, but it's an exciting time at least.
Yeah, I mean, I think I've talked about this in some other places where people don't remember the before times when everyone complained about not having any choice, and now everyone's complaining about having too much choice. So it's kind of one of those, as you said, we went from having a single flower that was kind of rickety and hard to change because everyone depended on it, had a lot of convention over specification, and now we have all these options, and now everyone's trying everything and seeing what sticks on the wall, and we just haven't, as a community, I think, decided as a whole what exactly we want to have. And so it's still being worked on, I think. Yeah,
for sure. All right, well, let's move on, and let's talk a little bit about this language summit. Just to sort of set the time frame here, I think people should maybe think about this as we were planning on doing this live at PyCon, like right at the end of the language summit, and for a whole host of reasons that didn't happen. So we're circling back here. All right. So I was hoping to catch you. Yeah, I do too. We could just blame Twitter. Let him be the scapegoat. So we were planning on doing this right after the show, and we're kind of circling back a little bit later. And I think that's probably good. There's a little more conversation going on around that. So that's all right.
Yeah. I mean, honestly, you and I were trying to DM each other on Twitter, and Twitter was delivering the DMs like half an hour late. And unfortunately, every time that happened, you and I had already gotten sucked into something. Well, wait, we were, it didn't work out. But yeah, there's been a little.
It's like, hey, let's meet over here in the next. Yeah, meet me down at the expo hall. We'll record the show, and then like half an hour later, it's already moved on, right? So yeah, that's what happened.
Yeah, I mean, honestly, I think it works at our benefit too, because the day we're recording this, actually, the official blog posts for the entire summit came out. And so for those of you who want to listen to Michael and I chat on about this, you can also go read the transcripts from Alex Waygood, who was nice enough to, as a core dev, to also take notes and write up the whole summit up. So you've now got two versions based on you waiting, us taking the time to actually get together to do that.
Absolutely. I had Alex on for the 2022 Python Language Summit review. So yeah, thanks to him for writing that up.
Yeah.
Yeah, for those out there who don't know, what is the Python Language Summit?
Yeah, so basically, as a distributed team across the globe at this point, it's kind of hard for all of us to get together and have a chat, basically. I mean, as I think we all know, having actual conversations together in a room, preferably, just because it's easier to catch people's facial expressions and stuff. But I mean, even if we could do it virtually as a live chat, we don't get to do that very often, right? We have core developers from all over various parts of Asia, North America, Europe, right? We have people all over, and so it's hard, honestly, just to be able to get together and have conversations. So what we've done is we've kind of scheduled ourselves 2 times where we all consistently try to get together as core developers. PyCon US, which includes this language summit, where we get together for a day. It's always on the Wednesday of tutorials before the conference starts, because for most of us, we're not attending tutorials. We might be giving a tutorial. And in those cases, usually the core devs just try to give them on Thursday instead of Wednesday. And then we have the core dev sprints, which are a week, typically in the October timeframe, where we all get together and just work as a group. And so this is just an opportunity for us to all get together and very specifically talk things out. And it's basically a summit at PyCon, which has a little schedule. It lasts a day, and we just talk and just try to work out some things that are a bit easier to talk about in a room. As such, when we actually do this, talks are scheduled for half an hour, but they're actually given almost like mini lightning talks, where you're expected to present for about maybe 5-10 minutes. And then the whole rest of that half hour is expected to be dedicated to conversation. So this is not a half-hour presentation to the room. It is a 5 to 10 minute setup for a conversation, and then we have a conversation as a group.
Right. I think getting together in person, even if you do it rarely, it makes a big difference for working on these types of issues. And just, instead of just filing some kind of PEP or a issue on GitHub, getting together and discussing it for a few minutes, there's so much higher bandwidth.
Exactly. And as I said, because we're all getting together, we get to say hi and all that, but the conversation can be much more fluid and dynamic. There's less delay. It just works out better. So
yeah, absolutely. All right. Well, I guess, let's dive into some of the topics that were discussed here. The very first one was this project called Coffee Break. So that's no, just kidding. The first project that actually is a main topic was, how do you say this? HPy, not HPy, HPy, I'm guessing, a better C API for Python. Yeah. Tell us what this is and what that presentation and proposal was.
Yeah. So for those of you who are familiar with PyPy, one of the difficulties the PyPy project has is trying to work with extension modules, right? Like, one of the wonderful things about Python being the glue language of the internet is we get used a lot to wrap various things written in languages other than Python, but it's also a curse in various ways. And one of them is, at least for PyPy, makes it really hard to support, because the C API doesn't exactly play into PyPy's JIT compiler and structure of being implemented in pure Python very nicely, right? Like, they can't JIT the code away when it's C code that's being dynamically linked and loaded in for PyPy to run.
And the C API imposes limitations on the Python code that would otherwise be free to do things like potentially have no GIL and other stuff in PyPy when it JIT compiles it, right?
Exactly. So Python C API was never designed really to be used by other implementations. It was designed for C Python to make it easier for people to do these extension modules. And as such, implementation details bleed out of that API, which don't necessarily play nicely with alternatives like PyPy, who, for instance, don't necessarily need to use reference counting, as a good example, right? Like, in the C API, there's literally incref and decref that stands for increment and decrement reference counting, which is how we do garbage collection in C Python. But guess what? That's not a requirement of the Python language definition. It just happens to be how C Python does things, which we will talk about later. But that causes problems. And so PyPy has always struggled with stay highly performant like they are when extension modules come into play. And so a bunch of the Py developers created HPy, which is a higher level C API that tries to not expose any Python implementation details. And yeah, just trying to make everything work at a for C API for extension modules at a C level that basically doesn't suck for everybody universally.
Sure. And
so at the
talks about
language summit,
building,
basically what happened was,
sorry, I was going to say, it talks about building universal binaries, right? These are I'm guessing C libraries that can talk C Python, but they can also talk PyPy and other runtimes, as long as that goes through this HPy layer, right?
yeah, basically there's two ways to take an so if you code your extension module to HPy, there's kind of two ways that you can have it produce an extension module, right? Produce a wheel. One is the one that is extremely fast for like CPython specifically, where it just acts as just another API layer, and it can just compile straight down to the C code and straight down to the .so file that ends up in your wheel, and you can just install it, and there's a zero performance overhead. It just works. The other one, though, is this universal ABI that they've created, where you compile your extension module in such a way that the wheel you install actually can be run on any other implementation of Python that supports HPy. And what it does is they also, HPy ships a little library that you also load in, such that these universal APIs, instead of calling C APIs directly, they actually call this library, this extra HPy library, basically, compatibility layer. And it handles how to call the implementation. So in this case, for instance, so if you build for this universal API and you were on CPython, you would install the CPython compatibility library. And what would happen is those wheels, that code would call through that compatibility layer and then into CPython. But if you're on PyPy, you would have the PyPy compatibility layer. And then that code would then call into that, and that would implement the right thing for PyPy. But the key point here is that compatibility library is a little thing. You install it once. It works for all the HPy-based universal built things that you installed. And then as a package maintainer, the idea is you only have to build it once, and suddenly it works across all HPy supporting interpreters, whether it's CPython, PyPy, or GraalPy. And so it just supposedly makes life easier because, once again, code for one C API, everyone gets nice, great performance, and you only got to compile once. It's kind of like the limited API for CPython writ large across multiple interpreters instead of just for CPython itself.
Right, right. So they mention PyPy, PyPy, and they mention GraalPy. So I'm not familiar with GraalPy. Where's that fit into the world?
That comes out of Oracle. There's a compiler toolchain from Oracle called Graal or Grail. I don't know.
Yeah, two A's. I don't know. Probably an umlaut in there.
Yeah. But it's a compiler toolchain for the JVM. And they happen to use the compiler toolchain to create an implementation of Python to run on top of this Graal toolchain, and it runs on top of the JVM.
Interesting. Okay, is it a little bit like a successor to Jython?
JVM, I don't know if it specifically allows plugging in Java code or anything like that. I just honestly don't know.
Got it. Yeah, got it.
But I mean, the general reason this was actually brought to the Language Summit was Antonio Cuny, PyPy and HPy, said, okay, PyPy, what can we do to get more usage out of it? like kind of, and as Antonio put it, is kind of a political ask more than a technical ask. Right? Can we help make HPI a bit more successful, or maybe somehow make HPI potentially even its official API somehow? And in the general discussion, I think what ended up happening was there were some questions over whether HPI Solutions was the best one or not, long term or medium term or short term, and exactly what that even looked like in terms of a political way of us saying as the CPython core development team, we recommend HPI. And I think in general, the way the conversation ended up going was, I think in general, people definitely applaud what HPI is doing, and definitely I would personally suggest projects that are doing extension modules consider looking at HPI as the way to do their extension modules. I don't think there's any negative to it at all. And if you're not doing some funky, I need the low level access to some weird thing in CPython, and you're wanting to support pipe, well, this is definitely something to look at. Whether there's something we specifically need to do on the CPython side, I don't know yet. So that could potentially come out to be more of a something the DOS, hey, make sure check out HPI or not. It definitely is pragmatically a good solution today, whether or not the CAP ever got to rewrite or a bunch of changes or some kind of talk about shortly. But sure. I think it's better, and the question really comes down to what, if anything, are the Python core development team kind of expect being asked specifically to do. And I don't know if we really came up with a specific answer to that question, but it's at least been raised as to what can we do to kind of just get at least the word out that it exists, and it's something that people should definitely get and consider.
Okay. It seems like it offers a lot of functionality to help package creators create their, if they're integrating with C, create them better. But whether it's an actual recommendation from as sort of a replacement than programming against a C API, that's still up for debate, huh?
Yeah, I mean that's the tricky bit. Is that where we want to go now? What I will say is the HPI team does have a shared channel on the Python core dev Discord server, so we do have a direct line to them and them to us, and we do chat with them. So there's definitely a decent amount of coordination going on there. It's just, I don't think since this happened, there's been any specific push to make anything specifically happen right now, but it was still not. But yeah, I would definitely recommend people, anyone wrapping some C code, definitely take a look at HPI and see if it does what you need.
Yeah, it looks like it has some cool.
It's nice to be able to have some nicely on top of it all.
Yeah, it looks like it has a sort of cleaner API. It has more debugging tools to help you, so probably worth checking out. All right, that brings us on to number 2. I still don't know what the C API is, and I've been using it for years, basically.
Yeah, and this kind of also leads into the next one, the CAPI. So that was from Mark. So that topic was from Mark Shannon, and then the follow-up was basically from Guido, where he just basically turned Mark's little section into an extension / more of a Q&A. So really, it was all 1 hour long block, and honestly, it was an 1.5 hour long block. It's all that bled together. The whole time from coffee break to lunch was just the CAPI, and basically what that was pointing out that there were some fundamental issues with the way the CAPI is designed, and there's like an implicit API in a way, right? Like anytime we update CPython, inevitably extension modules end up being broken, and it's typically not on purpose. It's just accidental because some part of the API happened to implicitly exist that we didn't realize was being implicitly relied on by people, or even maybe they explicitly relied on it and just didn't tell us. And so we will change things in a new release, which will break a bunch of extension modules, and we just didn't mean to, right? Like we'll move some thing in a struct and suddenly code breaks because they didn't think, because that struct had to be private to us, but the users didn't consider that. Or, oh, we changed some semantics that people thought were totally part of the design. And it's like, no, it was never meant to actually work that way and not to be relied on, but people did. So Mark's section, along with Guido's, was kind of pointing out the fact that we have that problem and what can we do to solve it. Mark also has grander ideas over almost a redesign. I don't know if Mark would really phrase it that far, but things to do to make things better. For instance, a lot of the CAPI basically returns a lot of models or -1 values, C ways of doing kind of like error return values, right? How do you signal an error? How do you say there's an exception you need to propagate? Versus if you compare to a language such as Rust, where they have like a result type, right? Where the result type is either success, okay, technically in Rust, or an error. And like Mark has suggested in the past, like, if we just always return to structs that had 2 fields, result, error, then you can very easily tell from every return did it succeed or not, because either result will be null or error will be null, kind of goes all that way. But it makes it very easy to tell what exception was. You don't have to go, like you do in CAPI, where you go, hey, something returned null. Okay, now I have to check, did an exception actually get raised or not? Yes or no? Okay, there actually is an error. I now need to return null. And kind of propagates versus, oh, I just returned the thing and it contains the exception that actually got raised. So there's a little less implicit kind of global state that way, because right now the exception is stored at the interpreter level versus just a return value.
Okay, so it's like the error is being passed in like a back channel, right?
Exactly.
You're like, oh, that didn't work. Let's go figure out what the problem was. Yeah, exactly.
Exactly. And like this was part of all of Eric Snow's work to bring sub-interpreters in for 3.12, was having to isolate all that stuff, because it used to just be a global variable in the C code, just that where the exception got stored. When you raise your exception at the C level, it literally just got stored in that value, which meant it was really easy to accidentally overwrite it and just forget to check for it, because some APIs have a kind of dual, something didn't happen or there was an error, you got to check, right? Like this is kind of goes back to the whole problems with the C API. And actually the one very concrete thing I think came out of this, which is really good, and I'm sure Michael will have this in the show notes, is Ritz, who's one of the core devs, started a CAPI problems repo, basically, to collect issues with the CAPI, whether it was consistency or performance or missing functionality, to try to work together with the community and other core devs to kind of identify where are we falling short in the CAPI. Because one of the big problems we've had with all these conversations, whether it's HPI or the reimagining what the CAPI could be, or et cetera, is we all know there are problems, but no one's ever gone down and actually written out what all the problems are. We just know there are problems. It's very hand-wavy, and we all want better solutions, but it makes it really hard to measure what the better solution is, because we don't know which solution is going to solve which problems, because we haven't written down what all the problems are. So a repo, basically on GitHub, is just meant to be an issue tracker where we're just trying to record what problems are with the CAPI. As I said, all the way from consistency to performance to literally just missing functionality. And I think that's the most concrete thing that came out of that whole section, was that repo, so that we can kind of try to have a more cohesive conversation, both as a team and as a community, around where the holes and problems are in the CAPI, so we can try to come out with a way to discuss the problems and find a solution.
The open source version of, in order to solve the problem, first you have to admit you have a problem and figure out what the problem is, right?
Yeah, exactly. Right. So now we're going to write down exactly what we're admitting to. I think eventually, so we'll have a PEP that'll probably summarize the findings of that repo of here where we're falling short, basically. And what does that do? does HPy solve these problems for us? Is there something else? Like, what do we have to do to kind of fix these problems?
Sure. Hi, I'm the CAPI, and I don't have exception handling. Nice to meet you, CAPI. So I suppose if this was the C++ API,
Exactly.
maybe that's at least this aspect that you're discussing wouldn't have been a problem, right? You just raise an exception in C++ and then catch it and convert it to a Python exception, right?
I don't know. It depends on who you are. For instance, at Google, where I used to work, once upon a time, exceptions aren't allowed because of how they muck up APIs, how their massive performance hits. So
sure.
I wouldn't even necessarily make that an assumption. So even if we did rewrite Python in C++, I don't know if we'd even use C++ exceptions. I honestly expect, I see there's a chance we'd do something in Rust before we switch to C++.
Yeah, I was just thinking if there's going to be a rewrite,
which I'm not saying we're doing, by the way, just to
proposing.
be clear. I don't want anyone in the audience reading into that.
Brett Cannon has said it. We're rewriting Python in Rust. It's going to be called Python 4. Is there going to be no issues about the adoption?
No, none whatsoever.
Okay, great. So first third of the day or something along those lines is all about the C API. Then there was a lunch, and not too much to say that, I imagine. But then some more internals on the runtime with the global interpreter lock and Sam Gross's work, which to me, from looking in from the outside, you'll have to let me know, but looks very promising towards opening up some concurrency capabilities of Python.
Well, so that's the interesting question with all this. So Sam's at 703, and he is submitted to the steering council. It's obviously not making it into 312. We've paid a 1 already, and since it wasn't accepted or rejected by the steering council, that's not going to happen. Make sure no one got their hopes up. Sam has updated the PEP such that it updated his implementation so that it caught up with Python 3.12. I can't remember exactly which stage. I think it was one of the alphas. I don't know if he's kept it completely up to date for the beta. And basically, the point for this was Sam coming forward and saying, I've written the PEP and it's now ready to go, such that I'm submitted to the steering council. The previous years where Sam's kind of coming in and saying, have this fork from 3.9 where I got rid of the GIL and here's the performance numbers. This one was more, I've gotten this far enough along that I am ready to have the steering council take a look, which kind of means you need to get core dev buy-in because the steering council tries to make decisions based on consensus. We try not to do it in a vacuum based on what the 5 of us think. We try to do it based on what we think the core dev will think, unless it's like divided down the middle more or less, or there's no obvious consensus, in which case we kind of use our own personal judgment. I think the tricky bit with this whole thing is obviously Sam's a very optimistic person. So for instance, he right now says that he thinks with some optimizations, the cost of this PEP will make the single-threaded performance have 0 overhead compared to before. Although I think right now it's like 5 to 6%. Those numbers might be a little off.
And that's been a big holdup where Guido didn't want to make a bunch of changes, reasonably saying to make Python better at concurrency, but slower in the single-threaded case, because still that's the main use case is single-threaded Python, right?
Oh, exactly, right? Like unless you take the time and effort to make your code concurrent, right, whether it's through threading or something else, it's going to be single-threaded, right? I think that's something everyone has to remember here is this is not a magic bullet in any way, shape, or form, and none of the concurrency is, right? Like the only way you get a win from this is if either A, you put in the time and effort to make your code threaded and have it do the right thing. And we all know how hard it is to write threaded code well, or you have to hope that the libraries you're using know how to write good threaded code and get performance wins out of it. So none of this is a magic, oh, we'll flip this on and magically get a 20% win like you got from Python 3 10 to 311 because of the faster CPython thing. This takes effort and work. The other complication I think with this PEP is I don't know if everyone fully realizes the cost. And it's not even a complexity cost to the internals, the complexity cost to everyone's code. Because I don't think people realize how much code out there really relies on the global interpreter lock implicitly. For instance, all of those extension modules that people install will suddenly become threaded, whether they meant for it to be that way or not. And all that C code wasn't written to be thread safe, you may have just accidentally shot yourself in the foot, because you get to implicitly, even with your extension module code, rely on the global interpreter lock, making sure nothing's running simultaneously. With SAM's change, though, that global interpreter lock's now gone, which now means your C code could be running in a thread and you don't know it. So you have to now make all of those extension modules threaded and thread safe in order for it to work and not stomp on your usual problems that you on your code, on your data or whatever, and the usual problems you have when you try to write multi-threaded code. So there's a cost here to doing this. And as I said, it's not even necessarily the complexity, which there is a decent amount. So this is not a freebie in that regard either. But I think there's that Python code that just hasn't been written that way to be expect to be run in a thread, right? Suddenly you have to start caring about that potentially if you just weren't prepped for that, right? So it's not a freebie, oh, well, if we just take this, suddenly the world will just be able to be multi-threaded if it chooses to be. It's the world would be made multi-threaded, kicking and screaming, or whether you chose to or not, and now you're going to have to make it work. So I think that's really the complexity here, is both the potential cost to single-thread performance, but also the potential cost of complexity to support it appropriately in extension modules specifically, and somewhat implicitly in Python code. And I don't know if people have really thought that through. Because once again, I think a lot of people are hoping I don't have to change my code, but all my libraries will magically use this and get faster, right? And
right.
I don't know if everyone's talked to those extensions to go like, hey, do you want this? And are you prepped to put in the time and effort to make this work? And I think that's really the big question. And to think honestly, and I will say personally, as a steering council member, those are the questions I'm going to have a hard time answering. And I'm going to be asking myself is, if we take this, what does that mean to the community? What is the burden we're asking everyone to shoulder on this? And will it be enough of a win for that to happen, right? Because the funny thing is if you look at other languages, they're moving away from threading, right? Like a lot of them are moving to more of a channel-based or actor-based model like Erlang or something else, where it's more of an isolated model where things are not shared everything memory set up like threading is, right? It's more kind of the sub-interpreter way of things. And yet we're
I was gonna say a little like Eric Snow's work.
Back to threading. So yeah, I just don't know. I mean, this is why you're hearing a lot of kind of hemming and hawing from my perspective, because as a steering council member, this is the stuff I'm having to weigh. Is I know everyone wants the magic wand to just, oh well, let's just be able to give threading to everyone who wants threading, but not everyone's going to want the threading support because there's a cost to it. And I just don't know if it's the right direction for us to go in terms of getting concurrency. Maybe the per interpreter GIL, right, that Eric's done with sub interpreters, maybe that's going to be a better solution. Because I mean, I'll fully admit, it's way easier for me to mentally think through how to launch another interpreter and send something into it and have it just work in isolation and then send back a result than it is to try to write multi-threaded code, especially when I'm using libraries that may not have expected to do that, right? Like think of all that global state that people store at their module level. All that stuff suddenly is now going to be running in a multi-threaded environment, and who knows if it's prepped to not have it accidentally tweak its code in a way that's not expected. And once again, all that C code you've been running in your extension module, you may not have really realized that you were actually relying on the global interpreter lock not to stomp on some global in your C code, or there's a global actually in the C code that you're wrapping, because if you're wrapping like some library, like who knows if that's ready. So you now have to take care of that. So once again, this is the toughness with this one. It's really cool what Sam's pulled off, to be very clear. Like I'm not trying to discount the hard work he's done, but this is, I think, the whole team and just that's the things we have to think through to decide, is it worth the cost?
Yeah, at the steering council level, you got to think of the well-being of the entire ecosystem. And I mean, just look at how hard it was for people to deal with just a change in what a string versus bytes meant. And this is, I would say this is probably bigger, at least at the C integration level.
Yeah, this is one of those things where it's not going to necessarily impact Python code quite as much, just because there's no way to like write half of a string to a variable, right? Like dictionaries, it might not be synced in terms of the order you expect things to be added to a dictionary, but I don't think there'll be data corruption because of the way Python and specifically C Python works. But at the C level, there's a much bigger ask.
I mean, think of a race condition with a free and then an access, and then you've got basically a pointer overflow type of situation, which sounds like security vulnerabilities and all sorts of badness. So yeah, that sounds scary.
Yes, thank you, C, in this whole memory unsafe world that we've unfortunately embraced rather heavily.
Yeah, well, 30 years ago it was a good choice.
Yeah, hey, I get why people did it back in the 80s, right, and how we ended up here. But these are the problems we face, right? When unfortunately we're trying to support all this legacy code that predates Rust and these other memory safe languages that we're all seemingly as a programming community moving towards. So it's tricky. Yeah. It's a really
tricky
question.
I mean, it's a bit of a challenge of the success, right? A victim of the success. We're approaching 500,000 projects on PyPI. Many of those depend upon C libraries or indirectly do. And what are you going to do?
Yeah,
you want to throw that work away.
As I said earlier, sure. It's a blessing and a curse to be the glue language of the internet, right? It's fantastic for Python's popularity and for the usefulness of this language, but it's a massive curse trying to integrate with such disparate systems that don't necessarily align with the way Python functions or make it easy to integrate with, and have their own inherent issues, and trying to munge two language communities and two different approaches to design and all that stuff into one running system in a single process. It's tough. So yeah, it's hard.
A bit of a Jenga tower to go pulling on those pieces.
Oh yeah.
All right. Let's move on to the next one, towards native profiling in Python. What is this about?
Yeah, so Joanna, who's a core dev is working towards her PhD at the University of New Brunswick, came and gave a talk about scaling, which is a sample-based profiler, and some work that they've done there to support sample-based profiling both in Python and native code. You could actually tell where it was, whether on the Python side or even C side if you're using an extension module. I will fully admit some of this was a little above my head. It was a bit academic. I think this all ties into Joanna's PhD. So it's obvious reasons very technical and difficult. But this, I will fully admit any of my PhD, so it goes past me. I know she and Pablo and Mark had a couple comments back and forth about it in terms of how much various approaches muddle performance numbers. Pablo, for instance, worked on memory and PyStack, and is very knowledgeable, very much knows how easy it is to skew data when it comes to all this kind of stuff. And so he had some concerns about the approach, and I think some of the brittleness, as he put it, of the approach. I don't know how true that simply is, or probably depends on your definition of brittle. And I know Mark's always concerned about how this generally impacts things and such, and does it still accurately reflect things, especially as like the interpretations and stuff. Really, what this was yeah, as I said, Joanna presented this solution. Whether you consider it acceptable or not, depends on who you are, that you can actually now use the profiler to sample both Python. Yeah,
profiling has this this quantum mechanical type of problem or aspect where if you measure something, you often can dramatically change the actual performance. It's like if you don't measure it, it's one thing, but if you measure it, it's another thing. It's hard to narrow down.
It's definitely tricky. I mean, profiling is always hard, right? Because profilers themselves take cycles and performance, and it's hard to kind of weed that out and not skew numbers. Do you do full tracing profiling or sample-based profiling, the pros and cons of each and all this stuff? Like, it's a really hard problem to solve, especially if you haven't necessarily designed the whole system around that concept. I will say there's some integration with the pool from the Unix world in, I believe, in Python 3.12. So there's another way to kind of get some numbers out that way. And I will say, like, we ship the C profile and profile modules in the standard library. Whether or not they really belong there is a separate question, which kind of leads into the next topic. But we'll either way, regardless. It's a space. That's why there's so many potential solutions to it. Is there's basically no universally accepted best way. It's all trade-offs, and it's just what trade-off with.
Yeah. Okay. It is a good question of whether or not it belongs in the standard library, and that was actually presented by you next, right? What is the standard library for? Standard lib for?
Yeah, so I am on my 5th and, at least for now, final year on the Python Steering Council. And if you were to ask me whether something belonged in the standard library, I couldn't give you a standard steering council answer. I gave you a personal answer. I gave you a guess. But Python as a project and steering council and core dev team as a group don't really have any guidelines over what the standard library is for anymore. Did, right? I mean, back in Guido's days, it was just where Guido thought should be in there. But in today's world, where we have nearly 500,000 packages on PyPI, and we have a thing called the internet, right? Like, everyone's got to remember how old it is. Predates Linux.
And you have a package manager and all those things, yeah.
We have multiple package managers. As we talked about earlier, we've let 1,000 flowers bloom now. There's a bazillion installed now on your system for Python. So it's just a very different world than what it was when batteries being included in the standard library were different. I mean, to take this analogy a little far, right? Let's talk about actually buying physical batteries. When I was a kid, back in the 80s and 90s, if you needed a battery, you had to physically go to the store to buy a battery. So you had to go out your front door, get in the car, drive maybe to the grocery store if you just need a AA, and buy it. If you need a slightly specialized battery, maybe you went to the hardware store, or God forbid, had to go find a battery store to get that funky battery you needed. How do you buy batteries today? You just go online and look for a shop that sells it, and it will just deliver it to your door the next day. Right? Completely different world compared to what it used to be, right?
It's like a really slow package manager. You go to the internet and you ask to get it, and it shows up the next day physically. It's crazy.
Yeah. But hey, that's the point, right? Like, you have PyPI, you can just do an internet search, go what I want, click, and then now it's installed, right? Before, the effort to find something reasonable was so burdensome. It was easier just to ship high quality things from the community in the standard library, just so everyone got it at once and didn't have to go through trying to find it and not probably find the thing, because we didn't have good search engines back then, right? I don't know how many of you remember Alta Vista. It ain't like it is today in terms of how good search engines are. So the whole point of this question was, what is the standard library for? What really should be in there? If we had 2020, now that we have 2020 hindsight in terms of everything, if we could stop and design the standard library today, what would be our overarching guidelines as to what that would be? Because there are over 300 top level modules but the point is, you took out the private ones, it's just under 300, right? Like it's a lot. And I argue too much, personally, from the perspective of maintenance. It's just a lot of code to maintain and just keep things going. People want new features added. You have to fix bugs. None of it's free. And so, as I said, from a steering council perspective, it's actually difficult because people go like, "Oh, I'd like to add this to the standard library." It's like, I don't know if that should go in or not, just because I don't have any guidelines to follow to answer that question. Right? Once again, they're trying to rule by consensus. Doesn't happen when there's no defined consensus over what should be in the standard library. And so this was meant to be a conversation around that. And it was kind of wide ranging. It didn't have any real conclusions. It mainly was some things that should not have happened in the standard library, right? Like tk-enter is like the glowing example of a regret we all have, I think, of shipping something in the standard library, because who wants to ship all of Tickle with Python just to have a GUI library that's cross-platform? And I don't think we need to have a GUI library in the standard library. Multiprocessing, honestly, is probably actually another good example, because it's so large and complex and hard to maintain. It's been a constant drain on the team to try to keep that going. And we've burned through, well, I can't even really say burned through. The original person who brought it in actually passed away. So the original maintainer is gone. And then Jesse Noller burned out. And then Davins seems to have gone. So like, we've consistently gone through maintainers of that module, and it's really hard to maintain. It requires a lot of cross-platform knowledge. It's really hard to get together, and it just is another example of something that probably shouldn't be in there. But after that, it's like, what is the definition? What should be in there? And no one had a good answer, right? Some people don't like having async IO in the standard library because it kind of overshadows things like Trio, which are probably a bit more nicely designed from a Python perspective. But if we didn't have async IO, would people have picked up async and await as well as they did? Zach, who is in the room, who maintains test and hypothesis, but that doesn't really play into this, and helps maintain Trio, said, well, if you look at PyTest is totally eclipsed unit tests, which does ship in the standard library, but Trio is not eclipsed async IO, even though you could argue Trio's got a better design to it. So there are examples in both directions of something in the standard library being good to be there and actually a drawback. And this is where this conversation just kept going around. It was just like, well, okay, so what are good examples and what are bad examples, right? As I said, tk-enter is a bad example of something that's you could call bad. Multiprocessing, async IO kind of fell on the fence of some of it's good, some of it's bad. Pathlib was considered good, right? Typing was considered good, right? It's just, it runs the gamut, and there was no clear kind of workloads or anything we could specifically say and all that. So
yeah, it seems to me that
I didn't get a clear answer.
No, that's sure. It's worth considering. I would say if it is there to support a core language element or even a keyword, like async and await doesn't mean anything without a thing to run async and await things, you know? That makes a lot of sense. So your multiprocessing example, like you only do multiprocessing by importing multiprocessing and then calling functions on that module. Like that seems like it could certainly be separated more, but you know, like, I don't know, I don't know what you do with async and await the keywords and how you make it a deep part of the language without there being something that you can count on being there.
Yeah, I mean, the thing I threw out there was things obviously required to make the language work, and that you just really are inherently tied to the language, like the AST module, right? Probably would make sense because you kind of have to keep that in sync with the language itself. But for instance, import lib needs to be there just to make it work, but do we have to actually expose it? That's like an interesting question. I also kind of threw out just basic, just like scripting, system administration kind of stuff, like be able to copy files around, right? Be able to write to a file, that kind of thing. Like the stuff that kind of like the OS modules, you could argue maybe shoot the shutl library, shutl, stuff like that. maybe it belongs in there, right? To keep that use case of just simple scripting where I just want to literally write a little quick script, point at it, and it's just overkill to have to create a virtual environment or install things, right? It just shouldn't be necessary. I should be able to just launch Python and run it and be done.
Yeah.
And then obviously some people point out like some language aspects of like defining like interfaces such as pathlib and such help define what is path like and the Dunder FS path interface and all that kind of thing, and et cetera, et cetera.
Sure.
My hope
there are things that belong there. Yeah, for sure.
Yeah. And it's, once again, no one has a good answer. My suspicion. So the goal of all this is I want to write an informational PEP as kind of a going away gift to the steering council before I step down at the end of the year, as kind of something they can lean on going forward as to, well, someone wants to add something to the standard library. Does it kind of meet the goals of this, the overarching guidelines of this PEP, yes or no? If the answer is yes, then okay, we can consider it. If no, then probably shouldn't be there. And that's kind of that was the big motivation for this, is that future PEP, which I have not tried to tackle yet because A, it's not been that long, and B, I know it's gonna be a bit of a slog. So not gonna.
Yeah, I can imagine. We should probably move on. We probably talked about this before. I'll throw out my final thought on this here. Is I don't know if it's actually a productive exercise to do it, but a 2023 view of what that might look like, maybe a better standard lib is we ship a very minimal set of what is the standard lib now and the CPython runtime, and then there might be a bunch of packages that are you pip install, but they could come, kind of pre-included. If I go to python.org and I download the thing, I might get, say, let's just pick on multiprocessing. I might get the multiprocessing module, but it's actually something I can pip upgrade and carries on like that,
That has been suggested in the past. The trick with that is how much overhead does that add to maintaining those things? Because obviously they now have a completely separate development process in terms of probably being a separate repo with all the packaging information and all that, and getting those uploaded and all that. It potentially makes it a little harder to update with the language, right? One of the nice things with having everything all in one spot is, at least for the core devs, it's easy to just do a broad look at code of a large code base and go like, oh, look, this feature is being used here and this way. I now got to go that repo and I got to go to that repo and I got to go to that repo.
Yeah.
There's also
a
licensing concern.
Honestly, yeah.
I don't know. There's a licensing concern, right? Because if we download them dynamically, like we do with pip using like Ensure pip, some businesses can't take that. They want it all in one contained archive, and that archive is what comes down with that license, and it's just done and taken care of. Now, I would also argue that's not our problem for that businesses choose to take that legal view, as it were, of what they will or will not accept. But it is something we do keep in mind, that some of these decisions do impact people based purely on the fact that their legal departments are extremely difficult to get any new code passed, and they've just accepted Python once, and so they magically get all of this wonderful code in through the standard library, through basically the standard library backdoor, as it were.
Well, that goes back to overseeing the ecosystem as a whole, the health of the ecosystem, not just does the code run faster, or can we push a new language feature or anything like that.
Yep.
Yeah. All right. We probably talked about what it is enough, and we still have no answer. Okay. Pattern matching. We're getting short on time. We got to do almost a lightning round here on these.
Well, luckily there's only 3 more, then lightning talks themselves. So this was presented by Sully, Michael Sullivan, and it was Yuri. Unfortunately, couldn't make it in time, so he was not there to present it. But basically, there was 2 parts to this. Basically, it was generally everyone likes pattern matching and thinks it was a good decision to put it in, and thinks when it's useful, it's really useful. But there's probably two proposed ways to kind of juice them up, as it were, and make them a bit more useful. One was the concept of a match, where objects can define whether they match something or not, and if they do match, what that object is. So kind of giving objects a bit more flexibility in terms of participating. Because if you look at the match statement right now, the way things match is either by checking whether something is an instance or something. You find match args as a way to kind of map things and to do the desugaring, as it were, from orders to attributes for the binding. But really, it all comes down to types. And with Dunder Match, you kind of get to decouple that and have a bit more flexibility on whether or not you want to claim something actually matches something in a case statement. I think in general, people actually liked that one and were more or less happy with it. Apparently, it was actually part of the original proposal for the match statement, but was considered a bit too much and was not necessary to make it functional on its own. So it got yanked out. But I would not be surprised if after appearance in a PEP to propose it.
It's a little like the Dunder enter, Dunder exit, allowing you to participate. Yeah, and like with statements,
exactly, or yeah, like add some overloading and all that kind of stuff, right? Just a way to be able to have an object say, "Hey, you're using me in a case statement to see if I match this thing that gets passed in. I'm going to say yes or no, and if it does, here's the thing. Here's how all this kind of you can do bindings to what you actually think the thing should be at the end, right? Like if you have clause to bind to the value or whatever. The other one was to use a bit more syntax to kind of have callables that you could use in certain places to kind of say, hey, here's a function that you can pass in certain spots and have that get called. And as long as the result of that call leads to this thing, consider that successful. I think if you read Alex's blog post on this and this example being used, there's like if you wanted a way to say like is something an int with an is int function, the idea would be able to say like is int and then an arrow to like true or false and have that be the way you match whether or not something was successful, right? Here's a thing with this extra clause that calls a function where the result will specify whether or not this case statement matches or not. Probably way better to read than to just listen to me try to explain it. But it is a bit more of an ask because it is syntax. I don't know if people bought into that one quite as much, if I remember correctly, but I think the Dunder Match people were generally in favor of just because it kind of plays into the way Python generally works anyway, and just allows for the proper amount of flexibility for those cases where do the is instance and the subclass checks that match inherently does just isn't quite enough.
Excellent. All right. And then mobile. This is one that is quite near and dear to my heart. Lately, I've been deep in the world of mobile. I've had at least 15 rejections from the App Store in the past couple of months, so I'm feeling very mobile right now. I wish it was Python code that I could have written, but it wasn't. So,
yeah. So Russell Keith McGee of the Beware project came and presented, and I think there was kind of two key points. One, Russell has now been working at Anaconda for about a year now, full time on Beware, which has meant they've gotten to move way faster and farther than the project has gotten to move previously. And get to tackle some real fundamentals. For those of you who don't, Beware has a newsletter that they publish monthly. And like one of their great things that they've now accomplished is they now have full testing of their Togo project and their GUI library, which is their GUI library. And actually some of the widgets now have full testing, right? Like, so they have full testing for their button widget, which sounds like not a big deal, but when you have to test across Mac, Windows, Linux, and web and make sure that button consistently looks the way it's supposed to look based on the way you decorate it and set it and have the buttons do the right thing and all that, it's a major accomplishment. And I think they've now expanded to like 6 widgets out of their whole plethora of widgets. So it's a big deal that Russell's getting funded by Anaconda to kind of make all this stuff happen. So they get to Anaconda for that. The other thing was Russell basically said he would like to get both Android and iOS support from CPython to tier 3 support. If you read PEP 11, which I am a co-author of, it defines the tier support levels for CPython in terms of compiled targets and platforms. And to reach tier 3, What that means is a platform will not have its code removed from CPython, period. Basically, as a core developer, I cannot rip out code from a tier 3 platform just because it's in the way, right? Or it's annoying. I kind of have to leave it there. Now, that doesn't mean I have to make it work. It just means I can't proactively rip it out, right? And in order to be tier 3, what has to happen is you have to have what's considered a stable build bot, which is a machine that basically is available to run after every commit to the CPython's main branch. And you have to have a core dev who basically signs up to provide technical support for that. But as I said, it doesn't guarantee things work. So for instance, if you go check out the main branch from the Git repo for CPython right now, tier 3 platforms are not guaranteed to function, right? They're there and were compatible and compilable and workable at some point in the past. And the code should be there for it to work, but it's not, it might not, just because something happened, people weren't paying attention, whatever. Basically, it will not hold up a release is the key point. We can do a release and have those platforms be broken, but it is the first step towards tier 2 and tier 1, which begin to actually block releases. And tier 2 actually guarantees that within 24 hours, the main branch will work on that platform again. So step 1 is to get to tier 3, and then we start talking about higher levels. But that was really where Russell ended up. Was Beware's in much better shape now that there's someone being fully paid to work on it. I believe actually Russell now has a coworker who's getting paid full-time by Anaconda to work on it as well. But also he has
it just seems like such a big project that without full-time support and focus, maybe a couple people, like you said, it's just, you're always, the mobile apps especially are changing so fast. And the way build and publish to them is such a nightmare that like that itself could be a full-time job. It's just keeping that working.
Oh yeah, if you look at the graveyard of Beware projects, it tells the story of how hard it is to keep up with all this stuff. And honestly, the massive effort that Russell has put in over like a decade or something crazy on this project, right? Trying to keep this all afloat and running, right? Like the number of times Russell's tried to re-implement Python for the various platforms, right? Like he had his Batavia project that was a rewrite in JavaScript, I think, to try to make that work because JavaScript's allowed on iOS, for instance. And then there's the VOC project. Like there's a lot of things Russell tried to make work, and it was way too much effort. And I think in the end, he just realized like, oh, CPython, if we can get this working here, is great. And has finally been able to, I think, through his effort and other people's efforts, his previous, like Javier used to help with the Android stuff, get it to a point where it basically works today. It's not perfect, and there's no guarantee that's going to keep working, but at least the pieces are there that if the other requirements for tier 3 get met, Android and iOS support could actually be near tier 3 support from CPython. And exciting. And Russell hopes by the end of the year. I will leave it up to Briefcase and the other Beware projects to make it so you can use it for anything, but at least be able to compile and test for it is a step in the right direction.
Yeah, definitely good to see mobile getting some attention, because that'd be really, really nice to be able to use Python for that. It's definitely one of the big areas that, Python doesn't really have a lot of capabilities in. There are some projects like Pythonista and some others that kind of sort of support it, but you wouldn't build, the next Airbnb decided to drop Swift and use Python. Like that's not being said with the current technology, right?
No, not yet, at least. I mean, I know that's Russell's grand goal in life.
Yeah.
And hopefully that dream comes true someday, whether it's via this or magic through WebAssembly or whatever, but it'd be nice to be able to do that. And I there's hope. I think we can get there.
Yeah, absolutely. Okay. Let's see what we got left. I guess that just leaves us with burnout, which, I think is maybe post-pandemic, even a little more prevalent than it was pre-pandemic.
It definitely didn't help. That's for sure. This was basically just a conversation Guido kicked off in the room about making sure all of us in that room help one another dealing with burnout and not hopefully reach the point that we even start having burnout. There have been cases where core developers have come and then just left, just disappeared. Sometimes it's for family reasons. Sometimes, as I've mentioned earlier, sometimes honestly people unfortunately pass away. Various reasons. They were doing it for work and now they're not doing it for work anymore. And they just don't have the time. But sometimes it's literally they just burn out. They just can't deal with it anymore, right? And work on a project the size of Python, both in its code base size and exposure and amount of things to do, can lead to some people getting almost addicted to trying to help out and really kind of putting way too much effort trying to make things function, or end up being too big of a target for people to come and harass, right? Like I will say the blessing and the curse of open source are the people, right? People are wonderful to get to know and do things with, but other people are absolutely horrible people who will come and do everything they can to make you feel horrible to yourself. And it's really hard to guard against. And
sure. And everything working out in the open means it's very clear who you should reach out to express your frustration towards on, say, a particular feature or language or library or whatever.
Yeah, I mean, look what happened with Guido and the Walrus operator, right? Like, it's the perfect example. Guido got so much flack that he stopped being BDFL. He just said, forget it. This is just too horrible.
It's a minor feature too. I just don't understand, but okay.
Oh yeah, exactly. It was a minor feature, but it touched syntax. And it just caused some people to just, I mean, this is a bit of a judgment on my part, but kind of flip out and just really go, I think, overboard in the criticism. But I mean, hey, I've faced this stuff too. And I mean, I will publicly say I spoke up about this, right? Like, I have set up some protections for myself to help deal with this. For instance, I take a month off every year where I stop doing any open source. I try to align it with a vacation, so I kind of minimize how much time I take away in terms of like not taking a month off and then taking a 2 or 3 week vacation on top of it. So I'm out for more like a month and a half or 2 months. But I try to do a full month where I unplug for any open source work. I mean, my work is actually open source anyway, so I can't get away from it entirely. But to be frank, it's way easier to deal with cranky people when you're getting paid to deal with it versus spending my free time on it. I mean, having your weekend
this for free for me and you're yelling at me, like, come on.
Exactly. The motivation is completely different.
Yeah.
So mentally, it is way easier to deal with. Now, that's not an invite for people to come harass me because I will block you and it still makes my day kind of suck. But it is way easier to deal with that versus, oh, I didn't go out and play tennis with my wife or go for a nice hike because I decided to do some open source that led to someone yelling at me. I also take one day off every weekend where I do not do anything where I can interact with the public. As I said, unfortunately, people are a blessing and a curse around this. So I guarantee at least one day every week, I will not have my day ruined by some random person on the internet deciding to be rude to me. And then I also reevaluate every year what I work on and kind of decide, is this still bringing me joy or not? Because working on something that is not bringing you joy anymore really contributes to burnout because then it starts to feel like a job and a job that doesn't pay well. So it just ends up feeling more of a drag. And I will fully admit, I actually was starting to feel burnout last year. Actually, I took my month off in September. When I came back in October, historically, I felt energized when I did it. And this year I didn't. I came back and just kind of felt like, oh, okay. So I've actually had to start cutting back on my projects. For instance, I was maintaining Pathlib because there wasn't an active core developer keeping Pathlib alive. And I kind of just took it on because I thought the community deserved it and it was important. And I realized it was kind of a slog and I didn't have a passion for Pathlib. It was just something I was doing to be nice and I kind of had to step away. So I did. So I announced that last year by January, I was no longer going to be the point person to reach out to for Pathlib bugs. Luckily, Barney Gale has come on as a new core developer and absolutely loves Pathlib and has been putting a ton of time and effort into it and seems to absolutely enjoy it completely and is hopefully not working towards burnout. I don't think he is. He seems to continue to really enjoy it. And he's doing a great job. So at least Pathlib didn't get dropped on the floor. But this is the kind of stuff we're dealing with, right? Is why it's a risk, right? When people do yell at core devs because they do just stop and then suddenly things stop improving and being maintained, and also why it's always just a risk for the people in the room. Because I'm somewhat notorious or well known for my phrase, I came for the language, but I stayed for the community. Well, it kind of plays into the core dev aspect of this as well, right? Like I continue to be a core developer because that room and that core dev in this summit are friends of mine now. Like I've been doing this for over 20 years. So I actually hit my 20-year anniversary the day before that of being a core developer since I got my rights. So I've got a huge chunk of friends in the world in that room. And the last thing I want to do is not get to hang out with them. And the excuse I get to hang out with them is I keep working on Python. But it also means we have to work and protect each other in that room. And it's the reason, and if that reason went away, it'd be sad. But this is why I worry about burnout with everyone, because I don't want to see my friends disappear. I don't want them to walk away, because that has happened actually in the past year. Someone who I considered a friend has completely burned out to open source to the point that they've completely cut open source out of their lives, which kind of means I don't really get to talk to them anymore. And that's sad.
That's a bummer.
But this happens. Yeah. And it's something that we just wanted to bring up. And so we had a very open and frank conversation about trying to identify the burnout, how to handle it, tell everyone to please reach out to friends and family and people in that room to talk to people. And I shared what I just shared here about my own experience with it and what I try to do to protect myself from it. And fully admit, as I said last year, I was starting to feel burnout. I think I've come around, but I fully admit I'm contributing less open source wise in my free time outside of work. And I'm still trying to I'm still doing it, but it's hard. And it's a hard thing to keep doing. And everyone's working on it, but key point is trying to help people not get to that in the first place. And that's
well, it also goes back to protecting the community and the ecosystem, right? Like if a core dev leaves that has all this historical knowledge and has been contributing a lot, that's a serious blow. That's maybe more important to keep them there rather than to add another pep, you know?
Yeah, and this is another reason why it's really important for businesses, it's going to sound a little weird, for companies to contribute to the PSF, right? Because this is what allows us to hire people like Wukash and the future deputy developer in residence that we announced at PyCon this year, right? Is that funding is what lets us have that stopgap. So to help prevent burnout becoming a massive problem that actually causes the project to collapse, we get to have that paid staff to make sure things continue to at least function, right? This is why it's so important that companies like Microsoft and Meta and Google have like core devs on staff that they pay to work at varying levels of percentage of their time on Python to help keep this stuff functioning. Like it's important. As I said, getting paid to work on it does mentally help with some of this pressure, because at least you're getting something out of dealing with that at the end of the day versus your volunteer time. So I hate to make it about money, but it does help in various ways.
Well, money is a proxy for time and energy as well, right? If you've got 7 hours of good programming and tech input a day and you spend 8 hours a day on that on work, like how much do you have left for open source, right? Versus on that day, your energy can all go towards it, right?
Yeah. And if it stops being enjoyable, why the hell am I going to waste my 2 hours on that? I'd rather go play Overcooked with my wife or watch Succession or go for a hike.
Yeah, for sure. All right. Well, we're out of time. So I believe that means we should just really quickly lightning through the lightning talks. If anything stood out to you that you want to give a shout out to, and then we'll wrap it up.
I'm also going to ask you to pull up Alex's blog post because I don't remember what was in the lightning talks.
Let's do it. All right. Lightning talks. We've got.
Right. So Dong-hee suggested we officially support the Bolt optimizer that comes with LLVM and Clang as an official thing. It's experimental option right now with dash enable Bolt in 3.12. Ironically, I think that actually caused some release problems. But yeah, if you love Bolt and want to see some optimizations, play with that. But the suggestion, I think, was to kind of make it more of an official thing versus the experimental that it is now.
Right. Okay.
The next lightning talk was Carl Meyer and Lazy Imports, which I believe you are a fan of the idea, Michael, if I remember correctly from hearing you talk about it.
Yeah, absolutely.
Carmine proposed PEP 690, which was going to which proposed adding lazy imports to Python itself. The steering council, which I was obviously on, rejected it. And Carl wanted to ask, well, what can we do to make it happen? So you just kind of brought up four ways to potentially do it. One was specific syntax, like lazy import, like lazy is a keyword. Come up with a way to eventually making it the default. Not changing the dict module. You can go read PEP 690 to see what that means, but basically there was some real underlying changes to dict to make that all happen. Or making names all lazy instead of just imports. And the way the room was surveyed, not changing dict was a really big deal. And then after that, the room was unfortunately split exactly between syntax or somehow making it the default.
Right. So instead of like import, you might say import, lazy import, to make it explicitly clear that this is happening, rather than just changing the runtime behavior.
Exactly. Or the other option is over time we eventually just make all imports lazy, and it's we just come up with a strategy on how to migrate the entire community over to that. And honestly, the room was kind of split, so I don't know what Carl's plans are now. And then the last one is from Amethyst Reese, who proposed, can we add a way to make modules callable? That's pretty much it. It's just literally is there a way to like do dunder call for modules. They have written a PEP 713 already that they have submitted to the steering council. We have not reviewed it yet, but it was just basically, we've got dunder get adder, and we've got dunder dir now for modules. Why don't we make dunder call a supported thing too? That was
excellent. That. Yeah, we have it on other places. It's just a sort of extender, right? Okay.
Yeah.
What is the default thing a module does? Do that. Cool. All right. Well, Brett, it's been great to have you here. Thanks for giving us this inside look into the Python Language Summit for 2023. I think it sounds to me like that's a meeting, a summit where a lot of things happen.
Yeah, we try. As I said, as you can see, a lot of stuff gets discussed, a lot of deep stuff gets discussed, and it's really convenient and useful. So thank you to all of the employers who were able to send people to PyCon US this year to attend and get to participate, and for all the core devs who did get to attend and participate. And yeah, it's a good time and it gets stuff done. So I'm really appreciated that we have it. And hopefully next year when we do this, you and I will actually be able to record very shortly after, because we will Signal instead of Twitter to try to message each other to schedule this.
Exactly. We'll try it again in Pittsburgh. So yeah. Thanks again for being on the show. It's always nice to have you. Have a good one.
You too, Michael. Thank you.
Yeah, thanks. Bye.